How's it going, ladies and gentlemen? Mr. Donahue here once again. This time we're going to take a look at how to name alkanes. So our objective is to convert between the name and structure for alkanes. So let's take a look at this, all right? So you got to learn a little bit about the chemistry language. And when we're naming these things, it's going to follow a general pattern of base and then the suffix. So the base is basically just going to tell you how many carbons are there. So if I got a molecule, how many carbons are there? And we have all of these like prefixes for the base. If there's just one carbon, it'd be meth. 2 will be eth. 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, and 9 non, and 10 dec. So we're going to use all those. And then the suffix is going to tell you what kind of molecule is it. Is it an alkane? If it is, then it ends in ane. If it's an alkene, then it ends in ene. If it's an alkyne, it ends in ine. So there's a systematic way to name these things. All right, so let's take a look at this first one. Well, my base is going to have to tell me that I got one carbon. So one carbon is going to tell me that I got meth. And that they're all single bonded is going to tell me that the suffix is going to have to be ane. So I got methane. So this is methane. Now I'm going to follow the same process for this one. I'm going to count how many carbons I got. I got 1, 2, 3, 4, 5, 6. So how do I say 6 carbons? Hex. How do I say they're all single bonded? I say ane. So I put those together and I get hexane. So this is hexane. Alright, well what if it's not just a carbon chain? What if I got like things on that carbon chain? Alright, so sometimes there are things on our carbon chains that aren't H. So we're used to seeing something like this and then all of these are hydrogens. Well, what if they're not hydrogens? What if they're more interesting than that? Well, we have still a system to name those things, right? So if you had an alkyl group, like for example right here, hey, that's not an H. Off of this carbon, I'd expect there to be an H, but it's not. It's an alkyl group. It's another carbon with hydrogens on it. Or you can have something, right, so the way we're going to name these alkyl groups is the same way. We're going to use the base to tell us how many carbons are on that interesting piece, and add YL. That's pretty much it. So that would be a methyl group. So this is a methyl group. If it had 2 carbons on it, it would be an ethyl group. If it had 3 carbons, it would be a propyl group. So it just follows that pattern. So it's the same thing, but with YL, telling us that it's a dingly-dangly, not part of the actual chain. All right, and we can also have halides, stuff from group 17, being dingly-danglies on our alkanes. So if it's a fluorine, then you say fluoro. So that's how we say there's a fluorine there. If it's a Cl, fluorine, it's chloro. If it's a bromine, it's a bromo. And if it's an iodine, it's an iota. Okay, so how do we name them? Well, the first thing that we're going to have to do is find the longest continuous chain of carbons. So this is going to be your base name. You got to find your longest possible chain. Second is you're going to have to number the carbons so that if there is a substituent or a dingly-dangly, it's given the lowest possible number. Then you name and give the location of each substituent group. And then if you have multiple substituent groups, when you go to name it, you just kind of put it in alphabetical order. And if you have 2 of the same kind, then you put like di. So if I had 2 chlorines, if I had like this, I would say that would be dichloro, right? If I had 3, then I would use tri. I use 4 tetra, 5 penta, and so on and so forth. All right, and then you list them alphabetically. So let's take a look at some examples. So the first thing I want to do is find the longest possible carbon chain. So I'm going to change the color of my ink here. So I could find a carbon chain that's 1, 2, 3, 4 carbons long, so I can do that. Or I can find one that's 1, 2, 3 carbons long. So that's not what we're going to do because we want to find the longest possible chain. Or I can find one that's 1, 2, 3, 4 carbons long. All right, so I have 2 that are the same length going in different directions. Which one do I use? It won't matter in this instance because you'll end up with the same thing. So let's see how we name it. So I find the longest possible carbon chain, which is 4 carbons long. Next, I want to give the numbers the smallest, so that I end up with the smallest possible number. So I can go, this carbon's 1, 2, 3, 4, and then my dingly-dangly is on my carbon number 2. Or if I numbered it this way, it'd be 1, 2, 3, 4. So I can either number it this way, where the number comes up as being the number 3, or you can number it going left to right, where the number becomes number 2. So I want to go this way. So I end up with the smallest number for my dingly dangly. So that's the way I'm going to number these things. So now you name it and give it the location. Well, how do I say I got 4 carbons? Bute. How do I say that they're single bonded? Ane. So you got butane. And now you're all right. Well, what is this dingly dangly, the substituent? That is a methyl group. And now I have to tell people where that methyl group is. It's on the second carbon. So that will be 2-methylbutane. Right? Put in alphabetical order. I don't have to worry about it because I only got the one. Another example. So same thing. Find the longest possible carbon chain. This one's pretty straightforward because it's got no twists or turns. It's again going to be 4 carbons long. Now you got to number it to give the smallest possible number. So I can go 1, 2, 3, and 4, and then my dingly danglies, my fluorines, can be on carbon 3 or 4, or I can number it this way: 1, 2, 3, and 4. And if I go right to left, then it's numbers 1 and 2, which is what I want to do. So I'm going to number it this way. Right? So I'm going to go right to left. So name and give its location. Again, how do I say that there's 4 carbons? Bute as my base, single bonded, ane, and now my dingly danglies are chloro groups. So I'm going to have to say chloro. And hey, I got more than just one, so I'm going to put dichloro in front of them, and now I got to say where they are. Well, I got 2 chlorines, so I need 2 numbers. It's going to be on number 1 carbon and the number 2 carbon. So it's 1,2-dichlorobutane. Alphabetized, don't really need to because there's only one kind of substituent group. All right, so let's take a look at this one. Find the longest possible chain. It could be 1, 2, 3, 4, 5 carbons long. It could be 1, 2, 3, 4 carbons long. It could be 1, 2, 3, 4, 5, 6 carbons long. So I'm going to have to go that way because that's my longest possible carbon chain. So 6. So there's my longest chain. Now I got to figure out how I'm going to number it. Am I going to number it left to right or right to left? Well, if we go left to right, it's going to be 1, 2, 3, 4, 5, 6. Now if I number it right to left, 1, 2, 3, 4, 5, 6. So this is my dingly dangly. This is my special part. Now left to right I get a 4, and right to left I get a 3. So I'm going to want to go right to left. So again, this one I'm going to go right to left. So I can erase all those numbers. Now I got to name it and give the location. So, well, I got 6 carbons. So how do I say 6 carbons? Hex. How do I say they're single bonded? Ane. Now how do I say the name for this dingly dangly? Well, it's a alkyl group with 1 carbon, so it's going to be methyl. And it's on carbon number 3. So it's 3-methylhexane. Put in alphabetical order. Doesn't really apply here. And then one more. All right, find the longest possible carbon chain. 1, 2, 3, 4, or 1, 2, 3, or 1, 2, 3, 4, or 1, 2, 3. So I want to go with 4. Well, which way should I do the 4? It won't matter. So I'm gonna look. I'll show you. Let's name this as my chain. Well, here are my dingly danglies. And now next part is number them to give the smallest possible number for my dingly danglies. All right, well, if I went left to right, it'd be 1, 2, 3, 4, and I'd have it on the second and third carbon for my dingly danglies. Or if I went this way, it'd be 1, 2, 3, 4. So either way, I'm going to get 2 and 3 as my carbon. So it doesn't matter which direction I count for this one. So I'm just going to go left to right because that's my preferred way, personally. So now I got a name and give the location of the dingly danglies. All right, well, how do I say 4 carbons? Butes. How do I say they're single bonded? Ane. And then what are these dingly danglies, these substituent groups? Well, they are methyl groups, so I got 2 of them, so I'm going to say dimethyl. And where are they? They're on carbon number 2 and 3. So it would be 2, 3 dimethylbutane. Alphabetized, don't really apply here. One more. All right, so I got 2 carbons. So I know that's going to be eth, single bonded, ane, and then I got to count what I got. I got 1, 2, 3, 4 things that aren't hydrogen. They're all the same, so they're all fluoro groups. So fluoro, and how do I say 4 fluorines? Tetra. So I got tetrafluoroethane, and now I got to say where they are. Well, I have 3 of them on 1, and then I have 1 of them on 2. Now, this is the part that may seem weird. You got to have a number for every fluorine group. If you've got 4 fluorines, you need to have 4 numbers, even if it's the same number multiple times. So how many do I have on the first carbon? 3. So I'm going to have to put 1, 1, 1, comma, 2. So that's telling me I got 3 fluorines on the first carbon and a fluorine on the second carbon. Right? So same process. There you go. So that's naming hydrocarbons. I hope you found that helpful. I'll see you in class. Okay, bye. Bring questions. Goodbye.